Hello everyone, welcome to GATE Academy. This is Richa Gupta with you all and I'll be dealing with open channel flow. So my dear students, you would have already encountered with this subject of open channel flow. Some students would have already studied it, and for some students this topic is very much new. So as I told you, we'll be dealing from the base and then we'll be proceeding subsequently. So could you tell me one thing? Already in fluid mechanics, we have studied regarding the pipe flow. Then, why was there a need to study the open channel flow? Come on, you should tell me why there is a need to study the open channel flow. Already in fluid mechanics, we have encountered regarding the pipe flow. Now, I'll tell you the answer. In fluid mechanics, you studied regarding the pipe flow. Fine. Now, here that is open channel flow. In short form, we write it as OCF. Could you just by seeing the name, could you get some idea what is this topic or what is this chapter going to deal about? Just come to this point. A channel section which is flowing, fine, and it is open. In layman's language, you can say the same thing only, right? I'll repeat again. A channel section or channel which is flowing and which is open. Now, this is simple, but to give this answer in a systematic and proper manner. While we deal with open channel flow is basically a channel where the liquid flows through it. But there is a condition. The liquid which is flowing through the channel, it is subjected to free surface, or you can say it is subjected to atmospheric pressure. I'll explain you with the help of a diagram. Suppose there is a channel. You have seen many channels, like when you go through a area, or you go through a treatment plants area, or you go through a canals, you can see many channel sections are there and they have different geometries. Fine. So now if this is a trapezoidal channel, fine. Now in this trapezoidal channel, what is happening, that in this trapezium, you can see this is a channel section basically, fine. This is the channel which is in the shape of trapezium and it is enclosed from three sides. But the other side is not enclosed or it is not packed, but it is subjected to atmospheric pressure. Therefore, this channel section can be called as open channel flow. Fine. So I'll write down the definition. Open channel flow can be defined as the flow, or otherwise I can write it can be defined as the flow where the liquid flows through any channel, where the liquid flows through any channel with a free surface subjected to atmospheric pressure. Fine. What I told you, I have written exactly that. It can be defined as the flow where the liquid, here specifically we deal with water, but it can be any liquid. Fine, it is not mandatory that the liquid has to be water. So now, where the liquid flows through any channel, but its surface, that is free surface, or you can say it should be subjected to atmospheric pressure. So you can see here, this surface is subjected to atmospheric pressure. Fine. Now, I'll ask you one question. Could you tell me, in this whole definition, I have written just one thing, that is through any channel. Now, I'll ask you whether this open channel flow concept, because this is the first lecture in which we are dealing with introduction to open channel flow. Fine. So here I'll give you the brief idea, or you can say a whole idea of what is open channel flow. Why was there a need to study open channel flow separately? Because this topic of open channel flow, as you know, that this topic is not for mechanical engineers, it is for civil engineers. So already when we were starting pipe flow, why there was a separate topic which we should study in this topic of open channel flow. So for this query of yours, you should have that, because what I believe is, when you're starting any subject, you should ask yourself questions that why this is happening, what is the, just we are starting this because it is important for GATE, what is the relation with the daily practicality of this topic. Fine, that will give you more clarity about the subjects and you will be having fun while you will be studying this. Fine. So now, coming back to this, I just want you to relate this, that liquid flows through any channel. I have written here any channel. So I'll be asking you that will this channel be a wide channel? Whether this concept of open channel flow, is it applicable for wide channel? Or can I apply this concept for narrow channel? Similarly, there can be n number of channels. I can name few of them for you now. Like as I told you, wide channel, narrow channel, a drainage channel having concrete lining, or a channel which is having lot of turbulence. Turbulence means the water is flowing in a haphazard manner. Fine. Similarly, a channel section is there which is calm and quiet and it is flowing smoothly. Fine. Similarly, there can be alluvial channels. They can be channels which are braided in nature. Braided means one direction is flowing, means one part of the river or one part of basically the water or the liquid is flowing in one direction while the other part is moving in another directions. So wide channel, narrow channel, and all the channels which I named you, could you tell me that is this concept of open channel flow applicable to a specific sort of channel, or is it applicable to any type of channel? So now, as I told you, I have already written through any channel. So if somebody asks you that whether it is applicable for wide channel, for narrow channel, for channel having lot of turbulence, this concept of open channel flow is applicable to any channel section, provided that the surface should be subjected to atmospheric pressure. Getting it? Now, I want you all that before continuing the topic, we'll be first dealing with how this pipe flow differs from open channel flow. Because if we are studying open channel flow, normally this is technicality that something would be different from the pipe flow. That's why there was a need to study open channel flow. Fine. So just one thing which I'll ask you in pipe flow before going to the differentiation part regarding it. In pipe flow, what you encounter? Like, this is basically a pipe. So, generally what happens in a pipe is, in pipes, flow occurs due to difference in pressure. Suppose at this point your pressure is P1 and at this point your pressure is P2. So because of the difference in pressure at both the sections, your flow through pipe will occur. While in the case of open channel flow, flow occurs under the action of gravity, or in other words you can say flow occurs due to gravity. Fine. So this is the first difference between the pipe flow and the open channel flow. Now, there is one thing which I'll ask you, fine, so that just you only tell me. I'll draw a pipe. This is a circular section of a pipe. This is one pipe and this is another pipe. Fine. Now what is happening? In one circular pipe, we are filling any liquid up to the full depth, while in the second section, circular section, we are filling the liquid up to a certain depth. Let it be half, 1/4, 1/3, any depth you name it. Now comes the question, I am asking you, out of both, which is the case of open channel flow and which is the case of pipe flow? Come on, look at this figure and tell me which one is your pipe flow and which one is your open channel flow. Come on, fast. So now, what is happening? You can see in the first one, as I told you, the liquid, or just name it as water here. The water is filled to the full depth. Fine. While in the second case, you can see it is not filled up to the full depth. Here, external pressure is being acted. Fine. And here, the surface is subjected to atmospheric pressure. Just one thing, to be specific, let us suppose this is a section of pipe. Now what happens? You would have seen also, you can relate it from your daily life. What happens is, if assume it to be a thin pipe specifically for now. If in a thin pipe, a part of the pipe is damaged, fine, it is supposed from this point, the pipe is damaged. What will happen is, water will start to come like this. Why? What is the reason? Because the internal pressure is greater than the external pressure. And this case, if I ask you that where you have encountered this case, so you can also relate it to your topic of environmental engineering, that, ma'am, in topic of sewer pipelines, we always not fill the liquid, or we can say always not fill the water to be treated up to the full depth. We fill it up to a certain height, that is half or 1/3 of the total height, because we leave some spaces for the gases to come out and accommodate in this space. Fine. So from here, seeing these two diagrams, what students do is, they say it is a pipe circular section, pipe flow. So they name it both of them as pipe flow. But it is not true. This one is your case of pipe flow, while this one is your open channel flow. This I am telling you because what happens is, you will be given 4 statements and you will be asked to write which statement, to mark which of the statement is correct. So for that point of view, you should be very clear what is open channel flow. I'll give you n number of diagrams, any number of figures. It is not that it will be trapezium or it will be circular, it can be of any shape. Fine. So you should be able to identify whether it is the case of open channel flow or it isn't. Fine. So I hope this concept is clear to you. Now, as I told you regarding the channels which is applicable in open channel flow, now we'll be moving to energy of flowing fluid in open channel flow and in pipe flow. So now, energy of flowing fluid in open channel flow and pipe flow. Fine. So now what is happening is, I am talking regarding the energy of flowing fluid. So now you have started regarding the energies already, right? Like potential energy, pressure energy, and what is else is left? Your kinetic energy. So here, as I told you that in open channel flow, gravity force is predominant. So here, let us suppose a channel section inclined at any angle, and this is your datum. This is your base. This is your datum. And flow is occurring. So what is happening is, this portion is your potential head. This one is your pressure head. And this portion is your kinetic head. Fine. Just one thing more. This line from where the flow is, you can say this inclination is there. This is known as TEL, and the full form of TEL is total energy line. Total energy line. While this portion of yours, this portion is known as HGL, that is hydraulic gradient line. Hydraulic gradient line. Fine. If somebody asks you what is HGL, you can also just let us suppose if somebody tells you in open channel flow TEL is less than HGL. Just by seeing it you can tell me. Is it possible? No, you can say, because total energy line is what? It is the sum of potential head, pressure head and kinetic head. Line joining equal points of this portion to that portion. Suppose there is another section. While in the case of hydraulic gradient line, it doesn't encounter kinetic head, while it is the sum of your pressure head and potential head. That is, line joining equal points of potential head plus pressure head is your hydraulic gradient line. Fine. So this you should know, because sometimes it's asked in the correct mark statements. Fine. So now already you would be knowing what is the expression for potential head, pressure head and kinetic head. But you might be having some queries, some students would be having some queries, so we'll derive it simply so that you'll be able to understand why this expression and from where this expression came out. So before going to the head part, nobody asked me, what is this head? What does this head means? Because you will say, ma'am, here you have written energy, but here you are talking regarding the head. So could you tell what is the meaning of head? So now I'll tell you. The meaning of head is energy. Whenever you take energy per unit weight of fluid with respect to any datum, then it is known as your head. Fine. What I said is energy per unit weight of fluid with respect to datum this is known as your head. So you had three heads: potential head, pressure head and kinetic head. So now moving to the derivation part, that is first one is your potential head. Potential head is also known as your datum head. Fine. So this potential head. Now what is happening is, suppose there is a body, any substance, the weight W is acting downwards. Fine. Now this is have to be lifted to any height Z. If this mass or this weight of a substance is to be lifted to any height z, then what will be the potential energy? Come on, tell me. I'm telling it again that any substance is there, any body is there, any liquid is there, anything is there which is to be lifted to a height z, then the potential energy in this case will be, potential energy in short we write it as P dot E dot, will be W into Z. Getting it? But am I interested in potential energy? No. I am interested in potential head. So potential head is what? Energy per unit weight. So what I have to do? I'll just divide with respect to weight. Fine? So with respect to weight, W. So from here, W and W will get cancelled out and potential energy per unit weight is equal to Z. You got one. That is one expression you got, potential head is equal to Z. Now, coming to the second one, that is pressure head. Although many students would be knowing these derivations, but as I told you, if you have any queries, you shouldn't keep it with yourself. Try to analyze how that query could be solved. So here, pressure head. Now, let us suppose I draw this diagram again. This is a channel bed, let us suppose. And let us take two sections here. This section, name it as 1, 1. And this section as 1 dash, 1 dash. Fine. Now, you tell me what is happening is, as I told you, flow takes place under the action of gravity. Water is flowing. So, when the water is flowing, so at any section 1, 1, you will be seeing a certain pressure is acting. So, what is this pressure? This pressure is your hydrostatic pressure. So, this pressure P is acting. Fine. Now, let us suppose that from moving from point 1, 1 at a section to point 1, 1 dash, the distance travelled or the displacement is L. Initially, it was at this point. Then the fluid moved to another section and the displacement at that time was L. So, now if I ask you what is the force or specifically what is the pressure force, because the force which is acting, that is your pressure force. Force is occurring because of what? You can see this diagram. Water is there. It is exerting pressure, that is your hydrostatic pressure. So, force is equal to pressure into area. Fine. Now, if force is equal to pressure into area, so how could you write it as? P into A into L. Fine. Now, sorry, L is not there, P into A. This is your force. Now, what is happening is, if I'll ask you what is the work done, if a fluid was at section 1 in 1, 1 section, it moved to a section 1 dash, 1 dash, obviously there will be some sort of displacement, and that displacement I told you was L. So now I am asking to you that what is the work done? So you know that work done is equal to what? Just tell me. Force into displacement. So work done is equal to force into displacement. That is, force is your P into A and your displacement is L. So this is your work. Now, work done is equal to energy. Fine, you know that both have the same units, right? So now, if I say that pressure energy is equal to P into A into L. Fine. And now I am interested in pressure head. That is pressure energy per unit weight. So what I have to do? Just simply divide it by weight. That is W. Right? Now what comes in my mind is this expression is too big. We have to minimize it. So could you tell me how we can get the end result in a concise manner? So you can say, ma'am, this expression of A into L, this expression of A into L is equal to V, because V is the volume of displaced fluid, is the volume of displaced fluid. Fine. Similarly, now I'll write it first. I'll do it step by step. P into V divided by W. Now, again there is some sort of modifications can be done. Here it is weight. So, do you know that gamma is equal to W by V? Fine. So you can write W as gamma into V. Obviously we can write, right? If you do silly mistakes, the one thing is, if here rho is there, then you would have taken it here mass. Because here gamma is there, you are taking it as weight. So now, P into V, in place of W you will write it as gamma into P. Fine. From here, your VV will get cancelled out and you will get pressure energy per unit weight as, shall I rub this portion? You will get it as pressure energy per unit weight, you will get it as P by gamma. This is your pressure energy per unit weight. Now, you know that gamma is equal to rho G. So, what else you find in your books is, somewhere you find it as P by gamma, you find it as P by rho G, or you find it as P by small w, that is unit weight of water, unit weight of any other liquid. Fine. So, these are the expressions which you encounter in your books. As for now, I will write it as P by gamma. So, here pressure head is equal to P by gamma. Fine. After this, we will derive the last one, that is your kinetic head, which is very simple. So, third is your kinetic head. So, for these all heads, you have to simply first derive the energy and then divide it by the weight. So, kinetic energy, you all know that it is half mv square. Fine. Now, W is equal to, that is weight is equal to mass into acceleration due to gravity. So, from here, can I write m is equal to W by G? Of course I can, right? So, here I substitute half W by G into V square. This is your kinetic energy. But I am interested in kinetic head, so I will divide it by weight. Here also, I will divide it by weight. Fine. So, here W and W will get cancelled out and I will get it as V square by 2G. This is your kinetic head. So, here kinetic head is equal to V square by 2G. So here, now I got the expression of all the three, that is potential head denoted by Z, pressure head is your P by gamma, and your kinetic head is V square by 2G. In OCF, generally what I do is, you can take it as P by gamma is equal to H, or you can take it as Y. Fine? As per your choice. H or Y, P by gamma, we'll be studying it in the subsequent chapters, like energy depth relationship. So where you get energy in that form, we write it as Y plus V square by 2G and all. That I'll tell you later. So from that purpose, P by gamma, you can denote it by H. In SAN books, it is H and or Y. Fine. So this, I hope this is very much clear to you, how we derive the potential head, how we derive the pressure head, and how we derive the kinetic head. Now, as we have derived all the energies, last what we will be doing it, we will be drawing a tabular chart or a differentiation chart between the pipe flow and that of the open channel flow. So, let me draw that. You tell me the points, that what is the difference. As I told you already, we have dealt with so many differences. So, tell me. Just one thing more. In this open channel flow, I have written liquid flows through any channel. It can be conduit also, any channel or conduit. Conduit means your pipe. But the conditions should be a free surface subjected to atmospheric pressure. The free surface or subjected to atmospheric pressure. Fine. So now, the difference between your open channel flow and your pipe flow. First one is, open channel flow occurs due to gravity, as I told you earlier, while pipe flow occurs due to the difference in pressure. So I can write open channel flow occurs under the action of gravity, or you can say due to gravity force. While pipe flow occurs due to the difference in pressure. Flow occurs due to the difference in pressure between two sections, due to the difference in pressure. This is your first point. Second point is the same which is being defined. If the liquid flows through any channel with a free surface subjected to atmospheric pressure, then it is the case of open channel flow. While if the flow occurs in a conduit without being subjected to any atmospheric pressure, then it will be the case of your pipe flow. So simply you can write it. The same point I am writing, okay? So flow, or you can write open channel flow. It is the flow where the liquid flows, same point, that is, flows through any channel with a free surface or subjected to atmospheric pressure. While here we will write it, it is the flow which occurs in a conduit, that is a pipe, which occurs in a conduit without being subjected to free surface or atmospheric pressure. Fine. The third point is, if you will draw the diagram of their velocity profile, or you can say velocity distribution diagram, what you will see is, we will study this velocity distribution of open channel flow in the coming chapters, but here while we are dealing with the difference part, I will tell you just here so that comparison can be done. It is something like logarithmic. You won't get the maximum at the free surface. The maximum velocity doesn't occurs at the free surface, while it occurs at a certain depth. So here the velocity distribution is logarithmic. If somebody asks you regarding the profile, this is logarithmic. While in the case of pipe flow, the velocity distribution diagram, that is, here you can see. Could you tell me what this shape is? What this profile is? This is parabolic. Fine. So here, in case of open channel flow, it is logarithmic velocity distribution, while in the case of pipe flow, this is logarithmic. Now, just for you, we'll draw for both the cases we have studied, right? The energies of the flowing fluid. So we'll draw what is the difference between the two. What is the difference between the two? Just let us see. What you have seen in open channel flow, this was your datum head, fine. This was your pressure head, P by gamma, and this one was your kinetic head, that is V square by 2G. While if I draw for pipe flow, occurs due to difference in pressure. So let us suppose this was the datum, fine. If this is your datum, so datum head, or you can say potential head, at this is the center. So this datum head is Z1 here, and this datum head is Z2 here. Fine. Here again, you can see this portion is your P1 by gamma, suppose this one, and this portion is your P2 by gamma. Here this is your hydraulic gradient line, right? I've told you regarding it, okay? And here also this is your hydraulic gradient line. Now, could just by seeing at both this in open channel flow and in pipe flow, could just by seeing at it, could you conclude something? Come on, just look at this. You should have a good observation skills, fine. Before I conclude something, you should be able to identify what is the difference between these two. I'll give you a hint, there is a difference in the hydraulic gradient line. Something is there regarding the hydraulic gradient line. Come on, look at this figure. Now, what you'll see is that in case of open channel flow, hydraulic gradient line is at the water surface. You can see it, this is the water surface, hydraulic gradient line is here. While in the case of pipe flow, the hydraulic gradient line is above the pipe surface, because the water surface is what? In the pipe. So it is above the pipe surface. Fine. So I can write this. This is your note point. This you should know. In open channel flow, hydraulic gradient line occurs here, or you can say is at the pipe surface, occurs at the water surface while in the case of pipe flow, hydraulic gradient line is above the pipe, or you can say pipe surface or water surface. Fine. So I hope now whole difference between pipe flow and open channel flow is clear to you. Why we are studying open channel flow? How is it different from your pipe flow? Fine. And I hope you will be clear with this, the velocity profile diagram. You don't have to worry how this came and what is everything calculation part. We will be dealing in the consecutive chapters. But as for now, I wanted you that you should have a clear idea what is your open channel flow and what is your pipe flow. Just one thing more, you would be knowing, but then also I should tell you, this P by gamma plus Z is what? This is known as your piezometric head. This is your piezometric head. Fine. And if you want to know what is the liquid here, what is the pressure, what is the height up to which it is being filled, so what you can do, you can install a piezometer here and you can see the level up to which it rises. Fine. So I hope now this is very much clear to you, all the differences between the pipe flow and the open channel flow. Fine. So I hope that after completing this part of the lecture, we will be moving to the next part, that is the types of open channel flow. So we will be meeting in the next lecture. Thank you.